Hi, I am Dr. T. Venkatesan, Professor in Electrical and Electronics Engineering from KS Rangasamy College of Technology. Today I am going to take the class Power Flow Analysis. Actually, the Power Flow Analysis is the fundamental study. It performs the power system during the planning and operation phases. It constitutes the major portion of the electric utility. This study is concerned for normal steady state operation of power system and involves the determination of bus voltage, power flows for the given network configuration under loading condition. Actually, the power flow study is very important. Okay, it is the fundamental study. Actually, the result for this power flow analysis, it helps to know the present status of the power systems required for continuous monitoring. So normally in our power system is a huge network. At each and every second, we should monitor the real power, reactive power, voltage and voltage angle at various buses. So this is very one of the important one. For that reason, we should know the fundamentals of power system analysis. Alternative second one is the alternative plans for system expansions to meet the increasing demand. So we know our population is increasing day by day, and also our load demand is increasing day by day. For that reason, in future we meet out the load demand. So this is the alternative plan. Normally in power system, a problem is the nonlinear algebraic equation. So iterative method only is used to solve the power flow analysis. So the conventional method, we are using the Gauss-Seidel method, Newton-Raphson method, and a fast decoupled method. Okay, introductions. The basic tool in the power system analysis. So the basic law, we know the basic law, Kirchhoff's voltage law and current law. So in power system problem, we are using the Kirchhoff's current law. We apply in all the buses, and also we find out the voltage, current, real and reactive power flows in the power systems. Actually, the very important, the future expansions to meet the increasing load demands. So already I told the load demand increasing day by day. So our aim is to meet the future load demand also. Significance in load flow or power flow analysis. So in planning side, the information of load flow analysis is essential for analyzing the effective alternative plans for system in future expansions to meet the increasing load demand. So next one is the economic scheduling. So we know the conventional power plant, the thermal is the major role in power systems. Normally in 67% of power generated from the thermal power plant. So by using the coal. Okay, so we know the coal purchasing from our neighboring country, and also we take from the coal pit. So the cost of the coal is one of the essential and it should be an economical one while operating the thermal power plant. So our main objective of our power system, we should run our power system in economic manner. So the economic scheduling is very important. For that reason, the load flow analysis is very essential. Next, control and operation of the existing systems. So we know the concept. Okay, we should maintain the voltage and frequency in our power system. Okay, we should maintain the voltage and frequency in power system. So the control and operation side, we should know the load flow analysis. Okay, and then future expansions. So this concepts already I tell in previous case. Next, the problems that can be studied with the help of load flow studies include optimization of the system losses. So we know the concept, actually the load generation and the load center are far away. So our aim is to minimize the loss. So each and every second we know the real power, reactive power, transmission power. So the losses should be minimized. So the optimization of losses, the load flow analysis is very important, and also stability checks. So we should maintain the stability of our power system. Stability, we know that constant voltage and constant frequency. So we know the Indian frequency 58, so we should maintain the frequency 58 continuously. Then next one is the general security of systems. So security of a system means the transmission line limits. Okay, it did not violate the voltage level. Okay, and so that one is called as the security. Transmission line violations, it should be avoided by using the load flow analysis. Okay, next, the transient behavior of the system. So the transient behavior is the very big role in our power system. So the load flow analysis is used to solve the following cases: optimization of the system loss, stability check, general security of system, transient behavior of the system. Okay. Next concept is the mathematical modeling. Already I told, actually mathematical problem of power system is the nonlinear algebraic equations. So iterative method is only solve this problems. So when we start this problem, we should know the bus impedance matrix, admittance matrix. So it is very essential. The first step is to solve the bus admittance matrix. Next, digital computer analysis. Okay, actually in our power system is a huge network area, so the computer only can solve the power system problem. So the computer, it requires the less computation time, and also it requires the less memory space. So it is very important. So while solving the big problem in computer, the computation time, it should be minimum, and also the memory is, it's also very less. Next, the in small and medium size problem, easily we carried out, and the hand calculation can be made. But in huge network, we should use only computers. Next one is the by using the load flow analysis, we also identify the overload, underload in the transmission line, and also in transformers, we are able to find out the over voltage, under voltage in various buses systems. So importance of power flow analysis in long-term planning: investigate the effectiveness of alternative plans and choosing the best plan for the system expansions to meet the projected operating state. Next, operating planning: choose the best unit commitment plan and a generation schedule to run the system efficiently for the next day load conditions without violating the voltage and line flow operating limits. So the long-term planning and the operation plan is very important. So both case, we should know the load flow analysis data each and every second. Steps for a load flow study: a representation of the system by a single line diagram. So we know in any power system, first we know how to draw the single line diagram. From this single line diagram, we have to obtain the impedance diagram. Next, we should know how to calculate the matrix, okay, Y bus matrix and Z bus matrix. Then the solution of the network equation. So we know the equations, load flow equations. So next class, I will plan and teach the power flow equation. Okay, next, classification of buses. Okay, we know the concept in load flow study. There are 4 quantity we should monitor each and every second, and that are real power, reactive power, voltage, and voltage angle. Okay, actually these 4 quantity in any bus, 2 quantities are known value or specified value. Other 2 quantities we are going to find out. So there are 3 types of buses. First one is slack bus, second one is the generated bus, and the third one is load bus. Actually in slack bus, a voltage magnitude and a phase angle of voltage are specified. Generated bus is usually a large capacity of generation bus is chosen as the slack bus. In power flow problem, we assume one generated bus as slack bus at which power generation is not pre-specified. After power flow problem has been solved, the difference between the total specified real power going into the system at all the other buses and the total power consumed by loads plus I square R loss are assigned to the slack bus. Actually, a slack bus generally we taken as the generated bus. In this generated bus, we didn't know the real power generation and reactive power. So in this slack bus, we should know the voltage and the voltage angle. So the generation power is compensated to the transmission losses, and sudden loss of any generation, and that power can be compensated by using the slack bus. A generated bus. Actually, in generated bus, there are two quantity known value. One is real power and the voltage magnitude. Other quantity are reactive power and voltage angle we can to solve. Next to load bus. In load bus, there are two quantities are specific: real power and reactive power. At the load bus, we should find out the voltage and voltage angle to be solved. Okay. Thank you. Thank you very much for watching this video.